Hello, good afternoon all. So today also we are going to discuss some of interview questions. Okay. So my first question is what we can do with the outlier. Okay. What are the things or what are the procedures we can do with the outlier? What we can do with the outlier? Okay. First thing, we can remove outlier. Okay, in which case we can remove outlier? Where we can say the my data is very much skewed to the left or the right. Okay, in that scenario we can remove our outlier. Okay, or it making a lot of data imbalance. In that case we can remove outlier. Other thing is don't remove outlier. Okay, in what case you don't remove outlier? Where your data is very much sensitive with the variables. For example, if I'm working with the bank data, where I want data or I want point to be very much extreme level, where I want to find out my candidate is fraud or not. In that scenario, I want the extreme value. Okay, because extreme value it makes that my candidate it is fraud or not in that scenario. Or other, if I want to give example, cancer patients. Okay, if I have a data where I want to find out that particular patient is have a cancer or not. Okay, in that scenario also we can't remove our outlier. Okay, because it is going to help there only. Okay, my next question is what is confusion matrix? Okay, what is confusion matrix? What is confusion matrix? Yeah, we can use remove, retain, trimming, initialization. Yeah, we can take a mean of data and we'll use that too. Yeah, in outlier. 3R technique we can use. Okay. What is confusion matrix? What is confusion matrix? What is confusion matrix? In simple word, we can say confusion matrix. It is a table. It is it it is table that is used to estimate the performance of the model. Okay. It tabulates it tabulates the actual value and the actual value and the predicted values in a 2 by 2 matrix. Okay, where we are able to see true positive and true negative. We have discussed yesterday what is true positive and true negative value. Yeah, that is nothing but what it is called as a confusion matrix. Next question is, what is bias in data science? What is bias in data science? What is bias in data science? Yeah. Confusion is one of our friend is saying that it is used for classification model. Yeah, it is because in regression what we are using then, we are use RMSE and RMSE root mean squares. Yeah, we are not using confusion matrix in regression. Yeah, very good. It is underfitting. Okay. What is bias in data science? Yeah. When it is under, lower, when we are having lower accuracy because of underfitting, we can say our model is biased. Yes. When algorithm is not strong enough, is not strong enough to capture the underlying pattern, okay, to capture the underlying pattern, okay, in data. Whatever we are having data, it is not able to capture that pattern. This may lead to low accuracy, okay, lower accuracy because of underfitting, because of underfitting. Okay, so that's next question is, what is PCA, or what is dimension dimensionality reduction? Dimensionality reduction. Yeah, bias is underfitting of model. Okay, my screen is not visible. Is that the same case with the others too? I think it is clear because even though I am watching, it is seems good, like it is clear. Yeah, participate, please reply in chat box, be active. Is it my screen is visible clearly or not? Yeah, I think it is clear. Please, Juhi, check your internet connection or do some settings. I think you have, have low. Yeah, PCA we use. Yeah, okay. Yes, Praveen. It is a way of converting the highest dimension dataset into lesser dimension dataset, ensuring that we are not lose any of information, or we might we lose some of information, but that's okay. Yeah. So dimension is the process of converting a data set with high number of dimensions to a data set with dimensions dimensions converting to a data set with a lower number of dimensions. Okay, but in what case we are doing this dimension reduction, we are make sure that, or while dropping the dimensions, we have to make sure that the remaining information we are still be enough to calculate our accuracy or to train our model. So we have to ensure that before go for PCA or in dimension reduction. Okay. So next question is, what is a normal distribution? What is normal distribution? Yeah, we can say high dimension space to low dimension space. Okay. What is normal distribution? Or when we can say our data is normally distributed. Okay. Yeah. So in data visualization tool to analyze how data is played out or distributed, okay, data can be distributed in various ways. For example, it could be a bias left or right, or it could be jump up like wave. Okay, so data may be distributed around the central value, that is mean, median. Okay, this kind of distribution has no bias, which data has no bias, either not left or right, or not in any bell shaped curve we normally speaking about. So if our data is, as our friends are saying, it's mean, median, okay, we having equal mean, median, not any bell shaped curve, not skewed in left or right. So then we can say our data is normally distributed. Next question is, what is p-value? What is p-value in hypothesis test? Okay. What is p-value in hypothesis testing? What is hypothesis testing? What is p-value in hypothesis testing? What is p-value in hypothesis testing? Okay. Normally p-value is, okay, 0.05. If p-value is 0.05, we can say it is strong evidence. Okay. If less than, p-value is less than 0.05, we'll say it is, okay, it is weak evidence. We can say it is and if p-value is less than critical value, okay, Then we can reject HO. Then we can reject H. Okay. In which case, if we having p value is, if p value is more than, okay, is more than the critical value. Okay, then we'll fail to reject HO. Okay, so this is how case. If it is less and we are p value is, if we having critical value, if we having critical value less than p value in F, and if our p value is 0.5, okay, and our critical value is equal to 0.5, then we can say weak evidence. Okay. The reverse case as above. And if we having p value is equal to p value is less than the critical value, then we can say strong evidence. Okay. 7th question is, how we can add to dictionary. Okay, in Python, how we can add to dictionary. Or we'll take on the next. How we can add to dictionary in Python. Using update. Yeah. How we can add two dictionaries? First of all, how we define dictionary is with a key and value. Okay. So here is my key and my value is 250 25. Okay, I am just going with the one key. And another, if I would like to give, is B is equal to I. Okay, just how we are going to add, just going to print okay, C is equal to print take A, okay, and B. I'm just going to take 2 star. We can go with the define function with the merge. Okay, you can do either way. This is the simplest way I think I find out. So that's why, yeah. What Supravat wrote is what? Is any keyword using for dictionary to add? Yeah, Supravat, what is wrote you are writing? Next question is what is selection bias? 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 Okay, okay. For previous question. Okay, no problem. What is selection bias? Sorry guys for interruption. Yeah, what is selection bias? Selection bias is the bias that occurs during the sampling of data. Okay. Whenever we are going for sample, we are taking from our data. We are going to take some samples. Yeah. And which is not a representative of population, okay, then we are going to say that our data is having selection bias, okay, where we are selection bias is the bias that occurs during the sampling. Okay, when if question is there when selection bias occurs, so it will be during the sampling. Okay. Next question is what is precision? What is precision? What is precision? Selection of individual group. Okay. Yeah. What is precision? Okay. Precision is nothing but going to calculate the correct positive predictions about our model. Okay. So what is the precision formula we'll know about is precision is equal to true positive divided by true positive plus false positive. Okay. So this is the formula by which from using this we'll get the precision, and precision is nothing but what we'll get the all correct value, accurate value, which are the we having correct predictions in our data. Okay. So we'll take next question is what are the benefits of dimension reduction? What are the benefits of dimension reduction? We have seen dimension reduction. It is nothing but what PCA technique where we are reduce our dimensions without fail or with the failure of minor data set or data. So that, but what are the benefits of that? What are the benefits of dimension reduction? The most important and first one I would like to mention is that once we reduce our dimensions, okay, the first one is the faster processing of our data. Okay, reduction in dimension leads to faster processing. Faster processing of the data. Second one, please guys, response in chat box. Okay. Second one, we can say it speeds up the process where we are going to, whatever operations we are going to, the reason why we are going to for high dimension is considered so difficult to deal with that. Okay. It leads to high time consuming. When we having lots of data and process also, it is time consuming. So while we are going to train our data, okay, so reducing dimension also speed up this process. It is easy to remove outlier, or we can say noise. Okay, and the last one is we'll get the better model accuracy. Okay. What is, next question is, what is RMSE? RMSE is nothing but what? Root mean square error. What is RMSE? Okay. Where you want me to write precision? You want me to write explanation about this? Yes, Rathod. Okay, no problem. Yes, quick reply. What you want me to write? Precision, you want to write clear? Because just before, I think 2 days, I have taken the same question. So that's why that was just a recap for that. Predictions quantifies the number of positive class, okay? Positive class predictions that are actually belongs to the positive class. Okay. Now it is okay, Rathod? We have seen what is precision and recall. So that's why I just wrote the formula. We also saw what is the recall. Okay, it quantifies the number of positive class predictions made out of all the positive example in data set. So what is RMSE? Yes. Ma'am, can you add one question about noise? Okay, okay. I'm not asking about full form of RMSE. RMSE is root mean square that we all know. Yeah, guys. Yes. Yeah, it stands for what it do? It used for measure the accuracy, measure of accuracy in classification model or regression model, guys. It is used in regression model. Okay. It allows us to calculate the magnitude of error produced by a regression model. Okay, and how we are going to calculate RMSE? We have to first of all calculate the error in the prediction made by the regression model. Okay, for this we calculate the difference between the actual and the predicted value. Then we square the error. Okay, and after that we calculate the mean of the square error, and finally we take the square root of the mean of the square error. You're getting, guys, or you want me to write this one, whatever I'm speaking? Please let me know. This number is nothing but what? Root mean square. Whatever I'm speaking, do you guys want me to written on this board? Yeah, it is metrics to check model performance. What I'm saying is how we are going to calculate RMSE is first we take the error. Error of what? Error means it calculates the difference between the actual and the predicted value. Okay. Then we square that error. That is the square error. Okay. After that, we are going to calculate the mean of that square. Okay. After we'll get the mean of that square, we are going to take a root. Okay, that's why it is root mean square error. Guys, if you want me to explain it again, please reply in chat box. Yes, Supravat. That is square root, yeah, mean, and then, yes, that is the simple, yeah. Thank you, Supravat. I would like to mention here what Supravat saying is, that is square mean, yeah. NP is we are going to use for calculate. Sorry guys, this is word, just whenever I'm typing space, it is going in capital, but N should be in small. Okay. We are taking square root of mean. Okay. And what is the error? That is y. Y prediction and y, the difference between actual and the predicted value. Okay. That is y test, and yeah, that is the simple way we can say it is the, this is the error. We are going to take a square of it, then we are going to take a mean, and then we are going to take a square root of it. Okay guys, so this is the simple one. What is RMSE? Yeah. What is, next question is, what is assemble learning? What is assemble learning? Yeah, applying multiple models and choose one best model. Yeah, that is assemble learning. Yeah, sometimes we can say data set are very complex, so it is difficult for one model to able to grasp the underlying trend or whatever features are available in data set. In such situations, we combine several individual models together to improve the model accuracy or performance. So this is called as model assemble learning. is called assemble. Yeah, guys, this is the definition, or what we can say about the assemble learning. Explain bagging in data science. Next question is explain what is bagging in data science. What is bagging in data science? Yeah, what is bagging? Yeah, bagging apply homogeneous model like decision tree and allow parallel processing. Yeah. Bagging is assemble learning methods. It belongs to assemble okay. We can also say that it stands for bootstrap. Aggregate. Okay. Where in this technique, what we are going to do? We generate some of data using bootstrap method. Okay. We in this state with the existing data, what we can say in which we can use an already existing data we take already existing data set and generate multiple samples of insights. So these multiple this bootstrap data is then we are going to use to train multiple models in parallel. It is parallel processing, which makes the bagging model more robust than the simple model. So in assemble learning, we are going to use sometimes bagging. What bagging is doing? It nothing but what? It is assemble learning method. It stands for bootstrap aggregating. Okay, and sum of data, whatever existing data we are going to generate n samples, and parallelly we are going to give it to our model to train our model. Okay, guys. So we'll stop for today. Thank you, guys.